For years, learning to code was treated as one of the safest bets for the future. A skill that would keep humans relevant as software became more central to the economy. But as AI systems become better at writing code themselves, a different set of skills is quietly becoming more important, and they are not things you can compile or deploy. Coding still matters, but it no longer holds the same position it once did. AI tools can now generate functions, refactor code, and translate ideas into working programs with minimal time and effort. What used to require deep technical fluency is increasingly accessible through natural language. That shift doesn't eliminate the need for programmers. It changes where human value sits. To understand the change, it helps to look at what coding actually does inside organizations. At its core, code is a way of expressing intent precisely. It turns a goal into instructions a machine can execute. Traditionally, much of the difficulty lay in writing those instructions correctly. As AI takes on more of that mechanical translation, the bottleneck moves upstream to deciding what should be built, how it should behave, and under what constraints. This is where framing, judgment, and context come in. Framing is the ability to define the problem before trying to solve it. In many real-world settings, the problem isn't obvious. Different stakeholders want different outcomes. Constraints conflict. Goals are underspecified or change over time. AI systems can optimize once a problem is clearly defined. In many settings, they perform less reliably when the definition itself is unclear. Humans add value by choosing what matters, what can be ignored, and which trade-offs are acceptable. Judgment is closely related but distinct. Judgment is not about technical correctness. It's about deciding when an output is good enough, risky, misleading, or inappropriate. AI systems can generate many plausible options. They cannot reliably decide which option fits a specific organizational, legal, or social context. That decision still requires human responsibility. You can see this pattern in areas like content moderation or medical decision support. AI produces suggestions. Humans decide whether and how to act on them. Context is the third layer, and often the hardest to formalize. Context includes things like history, incentives, culture, timing, and unintended consequences. It shapes how decisions land in the real world. Two identical outputs can have very different effects depending on when, where, and how they're used. AI systems operate on patterns. Context often lives outside those patterns, in tacit knowledge and lived experience. Together, framing, judgment, and context form a skill set that sits above execution. This doesn't replace technical skills, it reframes them. Coding becomes one tool among many, rather than the defining capability. The person who understands the system, not just the syntax, gains leverage. There is a credible counterargument here. Some argue that AI will eventually handle framing and judgment as well, that with enough data and feedback, systems will learn context just as they learned language. There is some truth to this, especially in constrained or well-defined domains. AI is already improving at suggesting problem formulations and evaluating outcomes. But these abilities remain probabilistic and indirect. They depend on past data, not responsibility for future consequences. As stakes rise, organizations often keep humans involved, not because machines are incapable, but because accountability cannot be automated away. Another risk is that emphasizing so-called soft skills becomes an excuse to devalue technical rigor. Framing without understanding systems can lead to poor decisions. Judgment without technical grounding can miss hidden constraints. The shift is not from technical to non-technical work. It's from isolated execution to integrated thinking. The most effective people increasingly combine basic technical literacy with strong framing and judgment. You can already see this pattern emerging. Teams using AI coding tools spend less time writing boilerplate and more time reviewing, integrating, and deciding. Product discussions focus more on what to build and why, not just how. Roles that sit between domains, product managers, system designers, technical leads, become more central as coordination complexity increases. The work moves toward orchestration. This change also affects how people learn. Instead of mastering a single tool in isolation, value shifts toward understanding how tools interact. Knowing how to ask good questions, evaluate outputs, and adjust plans becomes more important than memorizing syntax. Learning becomes less about accumulation and more about navigation. None of this means coding is obsolete. It means coding is no longer the scarce part of the system. As AI lowers the cost of execution, human contribution concentrates in places where meaning is negotiated, risk is assessed, and direction is set. Those skills do not disappear when tools improve, they become more visible. The future of work is often described as a contest between humans and machines. A more accurate description is a redistribution of effort. Machines take on more of the translation and repetition. Humans focus more on intent, evaluation, and responsibility. Framing, judgment, and context are not new ideas. What's new is that they are no longer hidden behind technical barriers. And as automation advances, they may become the clearest signal of where human work still matters most.